Hello, this is Module 5 Investigation 1. We're talking about the bottle problem, so modeling covariant relationships. So number 1, examine the bottle given below image in the bottle filling with water. So sketch the graph of the height of the water in the bottle as a function of the volume of the water in the bottle. So it would be nice when we really had that problem doing in class and then as we're bottles and then as the lab, but yeah, we can do it right now. So we're just gonna imagine, okay? So what I'm gonna do is, okay, let's say we have some small cup, and then there's a water filled in, and then this is amount of water we're gonna pour in the bottle. Okay, so same amount of the volume, and then we're gonna pour it in, and then let's see how much of the height and then that water can reach to. So, but as you notice that the bottom is very wider than, and then it gets a narrow to the top until it gets the up to here, right? So, which means at the beginning, maybe the amount of water maybe the filled in about this much of the height, right? And then when you pour it in second times, it might be goes a little higher, right? And then when you do the third times, it's gonna be a little higher too, right? And make a little higher because the base is getting smaller. Okay, and then higher. And gets a higher. And maybe gets a higher here. Okay, so what you mean is at the beginning, of course, there's no water, which means there's no height. But 1 cup of the water, maybe this much height goes. And then 2 cups of water, maybe a little higher. And third cup goes higher. So there'll be a 1 cup, 2, 3, 4, 5, 6, 7 cups. So 1, 2, 3, and then 4 cup, 5 cup, 6 cup, and 7 cup. But after 7 cup, and then this is actually the constant to fill it in. So you might have a little bit higher, but it's not that narrow much. Okay, so when you do this, you might have a graph like this one. So the B says, based on your graph, describe how the height of the water in the bottle changes as the volume of the water in the bottle increases through the domain. So which means I want to say while the volume of water grows slowly, the height of water grows faster. Okay. Okay, and then number 2, we need to watch the animation to see this, but I can show the animation right here. Okay, so let's do the number 3 on the next page. So in number 3, now we're gonna have a graph already. So we can think about the graph is different from the number 1. So we might have a different types of the base, which is the bottle. Okay, so what want to do is they already poured it in the water in the bottle to make a graph. Okay, so when you have a 0, of course there's the 0 height, and then the volume 1 cup makes about 12.5, and then 2 cups about I want to say 17, and 3 cups is about 20, and then 4 cups about 22, and 5 cups about 23, and 6 cups about 25, 7 cups about 28, 8 cups about 32, 9 cups about 45. Okay, and then on the last column, I'm going to put the difference between the 0 centimeter to the 12.5, which is 12.5 increase, and then 4.5 increase, 3 centimeter increase, 2 centimeter increase, 1 centimeter increase, and 2, 3, and then 4 as a 13 here. Okay, so B, use the graph of F, the table value of the answer following the questions. How does the water height change as the volume change from the 0 to 4 cups? So when you look at the the graph from the 0 to 4 cup, right? So as you notice, it's been increasing, isn't it? So the height is also increasing. But how does the change in the height as the volume change? Okay, so 0 to 4 cup, which means when the water was zero as a height, but 4 cup is 22. So it will be 22 minus 0, which is 22 centimeter increases. Repeat the 1 and 2 for the volume change from the 4 to 9. So if you look at the 4 to 9, from the 4 to 9, of course it's increasing too. Okay, so it's also increasing. And then number 2, how much increasing? So 99 cup makes a 45 centimeter, and then 4 cup makes a 22 centimeter. So it becomes like a 23 centimeter increasing. Then find the function average rate of the change over the interval from the 0 cup to 3 cup. So which means you have to find the f of 3 subtract f of 0 over 3 minus 0. So f of 3 you can see as a 20, 0 is a 0 over 3. It's about 20 over 3, which means 6.666 centimeter per cup. And then find the function average rate of the change from the 5 cup to 9 cups. So we want to see the 9 cup height and 5 cups height, 9 minus 5. And then f of 9 is a 45, f of 5 is 23 over 4. And then it's going to be 22 over 4. So it's about 5.5 centimeter per cup. And then we want to draw the picture of the bottle that will be the produced volume and height relationship conveyed in the table, a graph of the F, and the label are landmarks on your bottle. And the graphs of the part A where the function behavior change in the important way, okay? So, but this time, the same cup actually at the beginning was getting faster. Okay, so which is I believe that you have a narrow base, and then it goes maybe up to 6 cup as increasing. Okay, increasing, right? And then after that is actually it start decreasing because the volume of the cup is actually the. Yeah, so I can believe this kind of the bottles that we'll see. So at the beginning was higher. Actually, the volume gets the more, and then the height is getting smaller, and then up to this point, and then when the volume and the height was when the volume was same, but you get the small the height is getting higher and higher. So this is yeah, both are the increasing still because it's going to be increased. Okay, so yeah, that's kind of bottles you can think about this. All right, thank you for listening.